Hello again, my name is Martin and this is another video in our series of videos explaining the functionality of ABES geometry control software. In this installment, I would like to talk a little bit about how we split errors in the casting process into casting errors and setting errors and how that relates to what we call the updated casting curve. I will be using the little example shown here on the screen. I will be simulating the casting process for the segment shown here in blue. And of course, this is the geoCon user interface. The segment here in blue is already set out. Both segments are of the same dimensions, 3 meters long each. Each segment has 6 control points with 3 control points at each face or each joint. The distance between the control points and the joint are 100 millimeters throughout, and we have 1 control point in the middle and 2 control points at 4.5 meters offset on each side. Of course, this green segment here will constitute the conjugate segment. The blue segment here will be the segment that we are casting, and that of course means that the bulkhead is here on the left side. I would like to start with a very unlikely scenario. I would like to start with a perfect cast. I'd like to assume that the blue segment here, which is already set out, is cast perfect. No deviations, no casting errors whatsoever. We can simulate this quite easily by clicking on Next and using the Set Ideal button. So the survey data in these cells and these cells for the conjugate segment, survey data is a perfect copy of the setting out copy. No errors. Accept. And this is what we get. No matter how much we slide this lever up and down, we can't see any errors whatsoever. And if we highlight our new segment here and look at the numerical data for this segment, we can see that the casting curve data is exactly the same as the setting out data, and that again is exactly the same as the old cast data here, and that is exactly the same as the UCC, the updated casting curve, to which I will get later. And if we look at the errors here at the back, we have 3 columns for X, Y, and Z for the casting error, and everything is 0, could be expected in a perfect cast. And we have 3 more columns for the setting error, X, Y, and Z, and again, everything is 0, as could be expected in a perfect cast. No surprises here. Now let's go back and introduce our first error. And I can do that by clicking on Correct. We still have the perfect data pre-filled into our cells. And I would like to fiddle with the new segment, the matchcast segment, first. I would like to assume that here is our control point in the middle near the bulkhead, and I would like to assume that the marker for this control point was not placed at 100 millimeters distance from the bulkhead, but instead at 1.1 meters. So a meter further into the segment than we had originally intended. Very pronounced error, so we can see something in the visualization here. And what we see is this control point in its as cast location is in fact 1 meter set back from the bulkhead. So this error that we've just introduced has not affected the shape of our new segment. It has only affected the location of our control point marker. Nothing to do with the shape, just the marker is in a different place than we wanted it to be. Of course, geoCon will record the new location of this marker. It's now cast in concrete, and it will use the new location, the as cast location, for all subsequent operations. Has nothing to do with the shape of the new segment, and everything to do with the location of the control point marker. If we look at the numerical data again, we see that casting curve coordinates are the same as the setting out coordinates, again the same as the S-cast coordinates. But if we go to the arrows here, we see that we have no casting errors, and that is an indicator that the shape of our new segment is still perfect, but we can see that we have a 1 meter setting error here for this control point down here. And what this means is that we have a perfect geometry for our new segment, but we have an error in the control point marker. And this is also reflected here. That meter can be seen here in the x-coordinate of the UCC. The UCC, and this is the first time I talk about it in more detail, the UCC reflects a virtual perfect geometry with the as-cast locations of our control point markers. So since we have no casting errors, the UCC, the actual segment geometry, is still the same as the casting curve geometry of our segment, but in the actual S-cast location of our control point markers is now reflected in the UCC. It's the updated casting curve. It's a virtual perfect geometry with the S-cast locations of our control point markers. And there is one more detail I would like to highlight here. The setting error for this meter error that we've committed is noted in a -1 meter. The reason for this is visible here in the visualization. The setting error is always measured in relation to the joint that a control point is associated with. This control point here is associated with this joint here. It's gone from 100 millimeters in this direction to 1.1 meters inside the segment. And as the x is positive rightwards, we've gone against the x-axis, so it's a -1 meter setting error in the syntax, if you like, of geoCon. So let's introduce an error now that actually changes the shape of the new segment. And this is what we will call a casting error. And to make it very visible here on the screen, let's assume that our conjugate segment is moved 1 meter away from the bulkhead, 1 meter in the x direction, that is, from the bulkhead, and therefore making the new segment, the matchcast segment, 1 meter longer than intended. Click on correct, set ideal, and if I move the conjugate segment away from the bulkhead, and of course we are using local coordinates here, whereby the bulkhead is at 0, 0, 0, and x direction is into the segments. The first line of control points in our conjugate segment is at 3.1 meters, and if it moves away by 1 meter, that will be changed to 4.1 meters. And we do so for all 3 control points. And of course, the second row at the far end of our setup will move from 5.9 to 6.9 meters. And if we accept that error, of course, or a warning, this is what happens. The segment itself is 1 meter longer than intended. The blue line is the setting out position of the joint, and the green area shows the actual as-cast position of the joint. And if we slide up and down here, we can see how that error is exaggerated by using this slider. So there is a shape change, a significant shape change for the new segment. Since we haven't changed the control point locations, we can see that this control point has stayed at 100 millimeters distance from the bulkhead. So in a way, it is where we wanted it to be, except not in the global system that we are seeing here, but it's still at 100 millimeters from the bulkhead. But the control points here at the back, it was going to be at 100 millimeters from that joint, but because we moved the joint a meter over and the control point stayed where it is, we now have a meter distance here as measured from the joint. So if we look at the numerical data for this segment, and if we go straight to the error data, we can see that the casting error, it's 0 at that one joint, but it's already 1 meter because it's 1 meter longer. The far joint has moved a meter away. It's plus 1 meter for the far face of the new segment. So the near face is still where it's supposed to be, but the far face has moved by 1 meter. And the setting error is different. It is to set the control points are still where they should be in relation to the joint at the far end, but they're a meter away from where they were intended to be at the near end of the joint. I would now like to talk a little bit about the UCC, the updated casting curve that we calculate here in geoCon. This is a geometry that we just calculate here in geoCon, but it becomes useful at a later stage, especially in module ASEMCon, the third module in our geometry control software suite. Let's assume that we act a little bit like on a harmonica, and let's assume that we compress the green as cast geometry here on the screen in a way that we push this face back to the blue line, to the casting curve geometry. So let's assume we take this joint here, which is of course a meter away from where we wanted it to be, and we squeeze everything together until the green line matches the blue line here. So let's squeeze the S-cast geometry of our segments so long that it matches the casting curve, the perfect intended geometry. And once we've squeezed all this together, and once our S-cast geometry is squeezed enough to match the perfect geometry, we then look where our control points fall within that squeezed system. So basically we take the S-cast geometry and we push it so long that it matches the perfect geometry that we had intended, and then we record where our control point will fall in this virtual harmonica perfect system. And this is what the UCC represents. The UCC, the updated casting curve, represents still the perfect segment geometry, but with the mapped as cast positions of the control points. And this is what they use. So if we do this here, and if we push this joint in from the green line here to the blue line here, the control point, this control point will probably move spot on its location that we had intended in our perfect shape. Here, this joint, we don't have to push at all. So this control point here, it will stay where it is, and it will be at a meter difference. And I'm assuming that this will be reflected in the data that we can check using the data button again. So here we go. These are the casting curve, the perfect intended locations. And this is the x-coordinate of these control point locations. 155.1 for the first row, 157.9 for the second row. in global x coordinates. And if we look at the UCC here, we see that the back row is indeed 157.9. So they've been pushed back and they've landed exactly in the spots that we wanted them to be. However, here at the front, we wanted them originally at 155.1, and they're staying where they are at 156.1. So in our updated casting curve, our control points have moved from 155.1 to 156.1. But as I said, this is a virtual geometry, and the S-cast location of the control points within this virtual perfect geometry. Of course, in a real-world casting situation, we will most likely always or almost always have a combination of casting errors and setting errors. The conjugate segment will probably end up in a slightly different location than we had intended it to be, and in setting our control point markers into the concrete, even if we are very precise, we'll probably commit small errors. So there'll be a combination of both, and maybe something akin to what I'm showing here on the screen. I've added some random errors here to simulate this situation. So this is a real-world situation in a way, and what geoCon does here, it will record the conjugate segment location and calculate the shape of the new segment. It will then record the S-cast location of our control point markers as we have surveyed them, and it will then map the joint back onto the intended perfect location and record the control point locations in this mapped position, so we get the UCC. And if we look at the data here, this is the result from such a simulated real-world situation. We have a combination of setting errors and casting errors, and our UCC here has also got the effects of this baked into its coordinates. Of course, setting errors plus casting errors is what we call the total error. The casting error affects the actual shape of the segment. The setting error reflects the difference in the control point marker placements from the S-cast location to the intended location.